Alright, last part of the notes for section 2.5. I'm going to talk about Descartes' rule of the signs. So basically what this is saying is the most or how many of a certain type of zero you can have. Alright, so if we have some polynomial, the number of positive real coefficients you can have is either the same number of sign changes, right? If we go from a positive coefficient to a negative coefficient, like if this was positive, this was negative, that's a sign change. This was negative, this is positive, that's a sign change. Or less than that by a positive even integer. Okay, so meaning if we have 3 sign changes, all right, we could have 3 or 1. Okay, but we couldn't have 2. All right, we couldn't have 0. If we had 6 sign changes, we could have 6. Positive even integer would be 2, so we could 6 minus 2 is 4. Another positive even integer is 4. 6 minus 4 is 2. And another positive even integer is 6. 6 minus 6 is 0. So we could have 6, 4, 2, or 0 zeros if we had 6 sign changes. Okay, this is the first number is always the number of sign changes, and then it goes down by 2 from there, all the way down to either 0 or 1. Okay, if you get to 0, don't go into the negatives, obviously, and if you get to 1, you don't subtract 2 anymore. So it's always subtract 2 when you come up with the number of possible zeros you can have. All right, and then for the number of negative zeros, you plug in negative x into the polynomial, and then you find the number of sign changes of f of negative x, and then same thing. If you have 4 sign changes, all right, you can have 4, 2, or 0 negative. All right, if you have 5 sign changes, you can have 5, 3, or 1. Okay, it's always going to be all odds or all evens when you do this. Alright, so let's practice it and see how we do. Alright, so we're going to determine the number of positive and negative real zeros of this. So f of x has 0 sign changes. Alright, it's positive, 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 positive. Because it's positive, the number of positive real zeros is the number of sign changes. There are no sign changes, so 0. Alright, and then we would subtract 2, but that takes us into the negative, so there's not going to be any positive real zeros. Alright, now f of negative x. So I plug in negative x everywhere there's an x. Alright, negative, an odd number of times is negative, so this ends up being negative x cubed. But a negative even number of times will end up being positive, and a positive times a positive 2 remains positive. Okay, oops, I didn't put the negative right there, excuse me. That should have been negative x also. Positive times that negative is a negative. Alright, then a 4. Alright, so there's f of negative x. Now we count the sign changes. From here to here is 1 sign change. From here to here is 2 sign changes. And then from here to here is 3 sign changes. Okay, so we have 3 sign changes, so 3 negative real zeros are possible. Alright, 3 minus 2 is 1 negative real zero is possible. Okay, but we can't have 2 negative real zeros. We can't have 0 negative real zeros. So what this basically is telling us is this polynomial, right? It rises left. It rises right. It falls to the left. So it's going to fall to the left. It's going to eventually rise to the right. But what we're saying here is all the zeros would have to fall over here. So if it's going to cross 3 times, 1, 2, 3, okay, can't do that. It's got to bend only twice. So it's going to do something like that. And then I wouldn't have this over here. Or it could possibly just cross once, meaning that it could do something like that. Right? But it can't cross over here. Right? There are no positive real zeros possible because there's no sign changes in f of x. Alright, so there's my function. I've just put it into the calculator. Hit graph. I see this in the standard window, or zoom 6. See that in the standard window? I'm going to alter the window a little bit. Alright, so I changed the window to this, negative 5, 5, 1 for x, negative 20, 22 for y. When I graph it, there it crosses, crossed on the negative side, and it bends. There's one bend, there's two bends. They're both subtle. It's not a complete change of direction like I drew here, but it's a subtle bend, and there's the two bends. There's the end behavior, falls left, rises right. So that shows you that it does do what this says. It has no positive real zeros. It doesn't cross over here. The number of negative real zeros it has is 1. Right, crossed right there, so it has one negative real zero. Okay, but if I just looked at the graph, I wouldn't see the possibility for 3 negative real zeros. So it's important that you understand how to use Descartes' rule of the signs to answer how many are possible. Okay, only one happened, but 3 were possible. It could have had 3 because of the number of sign changes we had.